Hi, I'm Adolph Oliver, and this is a video clip on factor by grouping. Now, this is a process that can factor four-term polynomials by itself, but we'll also be making use of this in some other more advanced factoring as we go on a little bit further. But here's the beginning idea with factor by grouping. If you have four terms in your polynomial, you can try this factor by grouping. Now remember, not everything is factorable. And if the process you're trying, be it, reverse distributive law, or this factor by grouping, or any of the things we'll be talking about coming up, if they work, then the polynomial can be factored. But if you can't find a combination that works, then remember that simply means that we cannot factor it by the techniques we know so far. So we just say it's not factorable. Well, anyway, one of the first things you always want to do here is check and see if there's a GCF in all four of the terms. If it is, and that's be the reverse distributive law, factor that out because what's left has smaller numbers and it's going to be easier to work with. Okay, so here we go. Here are four terms for us. Notice the numbers don't go all the way through and the x's don't go all the way through. So that means there's no GCF. So we're going to try this factor by grouping. Now, we know all the techniques for this. All we do is take these four terms and split them up into first two and last two. Here they are. Then we do reverse distributive law on each pair of these. So let's show you how it works here. And we'll see if we can factor this guy. Looking at the first two terms here, we see there's a common 3 that we can factor out of both the 3 and the 6. And the lowest number of x's we have is 2. So 3x squared is going to be the GCF of the reverse distributive law on these two. And now we put the leftovers inside the parents. Well, what do we have to multiply 3x squared by to make 3x cubed? We're just missing one more x, so there it is. Then what do we have to multiply 3x squared by to make plus 6x squared? Well, we have exactly the two x's we need. We just need to multiply by 2, so x plus 2. Okay, there is the reverse distributive law factorization of the first two terms. Now, here's the key. You see this x plus 2 in parens here? If it shows up in this second guy, then we're in business. Well, gee whiz, it's not too hard to see here. Notice that we want x plus 2, and boy, we're looking at it. So here's something that's pretty easy to see that's going to work. Now, if you happen to have exactly what you want, you still have to factor a GCF out. So this is the one case where factoring a 1 out is what we do. And if we factor out a plus 1, the signs will be exactly the way we want them. We'll talk more about that in a moment. So notice, if I factor a plus 1 out of this, what do I have to multiply the 1 to get x? Well, I need to do an x. And what do I have to multiply plus 1 by to get plus 2? Well, plus 2. So plus 1 times x plus 2 gives me exactly what we have. Well, this one's going to work because notice we have the common quantity x plus 2. If these guys match, then you can factor it all the way down. This becomes your GCF now. So it goes out in front, x plus 2, and then in your parens beyond that you put the leftovers. Well, the leftovers are particularly easy to see here. You factor out the x plus 2. What's left in the first guy? 3x squared. Factor out the x plus 2 here. What's left? A plus 1. Okay, here it is right here. This is your factorization of this original four-term polynomial. If you were to use distributive law, actually, two polynomials here, just multiply this by good old FOIL, and if you FOILed it, you'd get the original answer up here. Okay, well, let's look at another example here and go through this. Once you get the process, factor by grouping is not difficult to do. Once again, look for a GCF in everybody. The numbers don't go all the way through. The y's don't go all the way through. So for the four terms together, there's no GCF. So we just have to take it the way it is. So let's take it first two and then last two. Okay, well, generally pretty easy to factor these guys because you only have two terms here. Y cubed and y squared, the GCF here is the two y's, so y squared. When you turn around and factor that out, what you'll have left from the first guy is a single y, and then what you need to multiply this second guy by is just plus 1. Y squared times y gives you y cubed. Y squared times plus 1 gives you plus 1y squared. There that is. Now, looking over in the second guy here, you see there's a common 5, so that's a GCF we're going to factor out. But here's what's going on. In the second guy, you always have the option of either factoring out the plus version of the 5 or the minus version. Only one of those works, and it's very easy to tell exactly which one it's going to be. Remember, this y plus 1, if it shows up, has got to come from these guys right here. In other words, this first guy has to come from the first guy here, this second guy from the second guy here. Compare the signs. You see this y here? You don't see a sign, but officially it's plus. Plus to minus, those are opposite signs. The second guy, plus to minus, that's opposite. If the signs are opposite, then you factor out the negative version of your greatest common factor. If the signs had been the same, plus to plus, something like that, then we would have factored out the plus version. Well, okay, you can see what's going to happen here. If you factor minus 5 out of both of these, you're going to get the y plus 1. Here it is. And, of course, this is common. So we can finish up the factoring, factor out that common y plus 1. We'll put it in front. And then the parents behind it will put the leftovers, simply y squared minus 5. Okay. Once again, if you were to FOIL this out, you'd get the original guy right on the button. Okay, well, let's take a look at some others here, which are a little bit more involved, not too bad. Okay, this first one up on top here, again, we've got 4 terms. If this had been something divisible by 5, I could have factored a 5 out, but it's not. The k's don't go through. So there again is no GCF in all of them. This is what we have right here. So let's break it up 2 and 2 and see if it's going to work for us. Okay, looking at these first two. There's nothing common in the 3 and 5, but there's 3 k's here and 2 here. So that means I can factor out a GCF of k squared. And the leftovers, well, I'm going to have a 3 and 1 more k here. So 3k. And then I got the 2 k's I need, so just minus 5 here. Once again, if this guy in the parents here shows up in the second one, then we can factor this. If it doesn't, if this is different, then you simply say you cannot factor it. Okay, take a look here. What's the GCF and negative 15k plus 25? Well, looks to me like all we can factor out is a 5. The k doesn't show up in both. Now, as usual, in the second guy, we have the option of factoring out the plus 5 or the minus 5. Only one of those works. And again, it's easy to see which way it has to go. Compare first here to first here, second here to second here, and just compare the signs. Plus here to minus here, the signs are opposite. Minus here to plus here, the signs are also opposite. So again, if the signs are both opposite, you turn around and factor out the minus version, so minus 5 is what we want to have as our GCF here. Now, what do we have to multiply minus 5 by to make it look like negative 15k? Well, it looks to me like it's 3k. What do we have to multiply negative 5 by to make positive 25? Well, let's see, how about minus 5? Because minus times minus will give me plus. 5 times 5 will give me 20. Well, look at this. Again, this one is factorable. We've exactly got what we want here. So factor that out to begin with. 3k minus 5. And put the leftovers, easy to see, k squared minus 5, in the second guy. Again, if you wanted to check this, FOIL it, you'd get this. Okay, well, hopefully you're getting the idea how it goes. Factor by grouping is not a difficult thing to do. Here's the next group, and we've got 4 terms again. Okay, let's see what happens here. There's no number that's going to divide into all of these guys at the same time. What do the A's do? No A's here, so the A's don't go through. The B's don't go through. And the R's don't. So there's no GCF for the whole bunch of them. So, okay, we can't do any improvement there. But let's get down to try and factor by grouping here. Okay, well, you ought to be able to see that the GCF in the first two here is going to be 3 and A. Okay, and if we turn around and put the leftovers in here, 3A would have to multiply by 2B to make this guy. And it's exactly what we want here, so you just multiply by 1. 3A times plus 1 is 3A. Okay, here's our candidate that if it shows up over here, we're in business. Well, let's see. What's the GCF here? We can factor out a 2 in the numbers, and notice we can also get an R out of both of them. So it's going to be 2R. But now we have the option of plus 2R or minus 2R. Let's see which one's correct. Notice that this would be a plus in front of the 2 since there's nothing written there. So plus to minus is opposite. Plus to minus is opposite. So since the signs are both opposite, we're going to factor out the minus version. What this does is just allow us to nail a thing right perfectly without having to write or erase anything. Anyway, what are we going to get? Well, negative 2R to make it look like negative 4RB. Got to multiply by 2 and you got to multiply by B, so 2B. And notice it exactly matches this, so plus 1 times negative 2R is, of course, negative 2R. Well, this is another good one. Here we go. We can factor out the common 2B plus 1, and the leftovers are easy to see. 3A minus 2R. Okay. Well, we're going along pretty good here. Let's look at another example down here. Again, oh, look at this. There is a GCF. I can get a 3 out of all of these guys. The R's don't go through. So notice this. I can factor a 3 out, and this will be what's left. R cubed plus R squared minus 2R minus 2. Now double check this. 3R cubed, there it is. 3 times R squared, there it is. 3 times negative 2 is negative 6 in the R. 3 times negative 2, negative 6. So we were able to get a GCF out of all of them. That means what's left is going to be easier to work with. Now remember, there is a standing law or rule in this factoring business. You must always factor as much as you can. So even though we did pull a 3 out of everybody, we've got to double check what's left inside to see if it can be factored more. Well, there's no more GCF. We got it already. So let's take them 2 and 2. Here we go. Notice the only thing common in these guys is an R squared. So, okay, and what are the leftovers going to be? Well, we have to multiply by another R here and plus 1 here. Okay, there's a common 2 here we can factor out. And you can see the signs are opposite, plus to minus opposite, plus to minus opposite. So that means we're going to factor out a minus 2. And if we do that, we of course get r plus 1. So we're in business here. A little bit of practice and you get pretty good at this. R plus 1 times, what are the leftovers? R squared minus 2. Okay. Well, let's look at the last couple of examples here on this. Okay. Here we go. The first one up on top. Let's look for a GCF. Again, at least 2 will go into all of these. In fact, I think we can get 4 into all of them, can't we? Nothing higher will work, so there is a GCF again. Let's factor it out. 4 times, factor the 4 out of the 12, it'll give me 3y cubed, minus, factor it out of the 16, 4y squared, factor it out of the 24, negative 6y, factor it out of the 32, positive 8. Okay, so notice what it did here is it made these numbers smaller, so the rest of our work here is going to be easier for us. Okay, again, we have to check and see if this guy has something where we can factor it more, and of course it's 4 terms, so we're going to try to factor by grouping again. Here we go, 2 and 2, and 2 and 2. Remember, this minus sign goes with the 6 here. Okay, let's see. Nothing common in the 3 and 4, but there is a y squared. Now, by the way, I think I may have forgotten something here, because I see it coming here. Jump back for a second to this last guy here, and you'll see that I forgot to grab this GCF we had, because it's part of the answer. And you need to write that right down here, because if you FOIL this out, you then multiply everybody by 3, and that's how you get the correct answer. Well, okay, I saw that coming in this one and thought for a second, did I remember to do that? There's lots of little details, and I forget them as often as you guys do, but hopefully you can go back and catch your errors. Okay. Here we are, back to the first 2 again. There is a GCF, y squared. Okay, now, what's left in here? Well, there's going to be a 3y from this first guy, and then minus 4 from the second. Now, as always, if this 3y minus 4 shows up over here, then we can end up factoring the thing completely. If it doesn't, then we stop and say it's not factorable and just give the original polynomial up here. Okay, notice between the negative 6y and the plus 8, there is a GCF of 2 between these. Now, of course, we got to figure out whether we're going to factor out a plus 2 or a minus 2. Compare the signs. The 3 here officially has a plus in front, so plus to minus, that's opposite. Compare the second guys. Minus to plus, that's opposite. The signs are opposite. If they're opposite, that means you factor out the negative version of your GCF, which was 2, and that'll give us the correct answer. So what do I have to multiply negative 2 by to make it look like this? Well, I need both a y and a 3, so 3y. Negative 2 times, what do we have to multiply 2 by to make plus 8? Well, we got to multiply by 4, but since this is negative, it's got to be a negative 4, because negative 2 times negative 4 does indeed give me positive 8. Well, once again, notice we've got our common guy here, so factor him out. 3y minus 4, and the leftovers, y squared minus 2. Now remember to go back and look and see if there was a GCF you pulled out, and there was. So be sure you come down and put that in the answer right there. Okay, one last guy to look at here. Here he comes. Let's see, there's no common number we can factor out. The x's don't go through, so no GCF, so we got to try it. Just 2 and 2, exactly like it is here. Okay, here we go. What's the GCF in the first two? Well, we can get a 2 out of the 2 and the 4. And we can get 2x's out of both of these. So 2x squared. And then what are the leftovers going to be? Well, what do you have to multiply this by to make that? A single x. And over here you have to multiply by plus 2. Okay, so if you distributed this in, you'd get these guys here. Okay, there is a GCF here. It's 5, isn't it? And of course, if you compare the signs, plus to minus is opposite, plus to minus is opposite. The signs being opposite, that means we're going to factor out a minus 5. Okay, well, what do you have to multiply negative 5 by to make negative 5x and x? What do you have to multiply negative 5 by to make negative 15? A positive 3. Okay. Oops, look at this. These guys are not the same. Okay? They don't work here. This is x plus 2. This is x plus 3. So that means we cannot factor this. Okay? And so you simply go back and say, okay, you just have to leave the problem unfactored like it is right here. Okay, well, there we go. That's the factor by grouping business. And we'll be making use of that as we go on further and other things we do, not just a factor by grouping.